if P equals 2, 3, minus 1 and Q equals minus 1, 0, 2, find A, P dot Q, the dot product, the scalar product, and B, the angle between P and Q. Okay, so P dot Q equals, it's simple as it's the x components times together plus the y components multiplied together plus the z components multiplied together if you have a z component. Here we do. So it's 2 times minus 1, 2 times minus 1 plus 3 times 0 plus minus 1 times 2. Okay, 2 times minus 1 is minus 2, 3 times 0 is 0, and minus 1 times 2 is minus 2. So that is minus 2 minus another 2 is minus 4. P dot Q. Now to find the angle between them, you use this formula. This is in your formula book. It says P dot Q equals the modulus of P times the modulus of Q times cos theta. Okay, so we are looking for the theta. So if you think about that, well, cos theta must equal P dot Q, which we've already worked out, over the modulus of P times the modulus of Q. So we are going to have to work out the modulus of P and the modulus of Q. So the modulus of P is going to be the square root of 2 squared plus 3 squared plus 1 squared. 2 squared plus 3 squared plus 1 squared equals 2 squared is 4, 3 squared is 9, 4 plus 9 plus 1, the square root of all of that equals root 14. Don't bother changing that into 3 significant figures, it won't help you at all. We're going to use it in a calculation. So in the same way, the modulus of Q equals the square root of 1 squared plus 0 squared plus 2 squared. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5, it's root 5. Okay, now often you will be asked for, it might say find the acute angle between the two vectors. Basically, if you've got two vectors, say, and what you do to find the angle between them, you can kind of move them so they start at the same place or something like that. Let's say that's one vector, and that's another. You could say, well, is that the angle between the vectors, or is that? So they're both angles between vectors. Basically, if you use, in this formula, if you were to say use the modulus of P dot Q, you will always guarantee an acute angle once you do the substitution. In this case, it doesn't ask me in particular for an acute angle anyway, but just be aware, if you ask for an acute angle specifically, one way to do it is to use the modulus of P dot Q. Another way to do it, if you do the working out and you get an obtuse answer, so as in you get this angle here, well, you can just take away from 180 to get the other angle anyway. But let's just use the formula book formula. So cos theta equals, well, it's P dot Q, which we already have from part 1, minus 4, over the modulus of P, root 14, times the modulus of Q, root 5. So theta must be the inverse cos of that. So cos minus 1, inverse cos, or arc cos minus 4 over root 14, root 5 equals. So go straight to your calculator. Inverse cos minus 4 over root 14, root 5. Root 14, root 5. Okay, so that does give us an obtuse answer, so we'll say that equals 119 degrees to 3SF. Just to prove the point, if I go back up here and just change that -4 to a 4, it should give you the answer of 180 minus 119, which would be, it should give you the answer of 61, just to prove a point. So you can see that works. So if we use the modulus of A dot B, or P dot Q in this case, or I think V dot W in the formula book possibly, if you use the modulus, you get the acute, always guarantee an acute angle. Unless of course the angle is 0 or 90 degrees.